Hello students, I welcome you in today's session of physics, and in physics I am going to present you the chapter number 18 which is refraction of light through a prism and scattering of light. You can see here this is the topic we have to discuss today. But before going to start the chapter, let's discuss what we have to study in the syllabus. You can see here this is the syllabus, and in the syllabus you have to study about the refraction of light through a prism, scattering of light, blue color of sky and reddish appearance of the sun, sunrise and sunset. Fine. So first we have to discuss what is the prism. You can see from the figure number 1, this is the figure of prism. So a prism is a homogeneous transparent medium such as glass bounded by the two plane surfaces, fine, which is inclined to each other at an angle. Here you can see these are the two surfaces of the prism. The two surfaces, which is your ABED and ACFD, from the figure you can easily understood, called the refracting faces, and the angle between them is called the refracting angle, or you can simply say the angle of the prism. Here you can see the line AD, this one. From the figure you can see that along which the two refracting faces meet is called the refracting edges of the prism. So any section of the prism cut by a plane of right angle to the refracting edges is called the principal section of the prism. Clear? So in figure ABC is the principal section of the prism. You can see from this figure what is the ABC. ABC is your principal section, this one, ABC. I hope you understood. Now come to the refraction through a prism, the second one. So you can see here this is the figure number 2, which is showing the refraction of through a prism. So what's going on here? You can see from the figure, let ABC be the principal section of the glass prism. So the angle A is the refracting angle of the prism. So we are supposing here a monochromatic ray of light PQ be incident on the face AB. This is your AB face or surface. So this ray is refracted towards the normal NQE. You can see here there is a normal which is your NQE, this one, and travel in the prism along OQR. So the refracted ray, which is QR, bends away from the normal MRE at AC and emerges along RS into the air. Clear? So thus PQRS is the path of the light ray which is passing through the prism. Now let us supposing that I be the angle of incidence and R be the angle of refraction at AB. This is the refracting surface. So R dash be the angle of incidence and I dash the angle of emergence at AC. Clear? Let delta be the angle between the incident ray PQ. You can see from this figure this is the incident ray PQ. This one PQ, which is producing forward, and the emergent ray RS produced backward. So delta is called the angle of deviation. You can see here this is the angle of deviation. Now how we calculate the angle of deviation? So there is a calculation of angle of deviation, that is the minimum deviation in triangle QDR. You can see here from the figure QDR. So the deviation can be written down like angle DQR plus angle DRQ. You can write it I minus R plus I dash minus R dash, or you can write it I plus I dash minus R plus R dash. So in the quadrilateral you can see from the figure above, triangle AQE and ARE are the right angles. So hence the sum of the angles A and E is equals to how much? 180. Then we can write here angle A plus angle E equals to how much? 180 degree. Or in place of A and E, you can write it R plus R dash, which we already find out. So you can see here R plus R dash plus E is equals to how much? 180 degree in triangle QER. You can see from the figure angle QER, this one. Clear? So from these two equations we can write here R plus R dash is equals to A. So substituting this value of R plus R dash in equation first, you can see here this is your equation number 1. So in place of R plus R dash we can write here A. So what is the deviation comes out to be, which is equals to I plus I dash minus A from this equation number 1. Fine. I hope you understood. Now we see that the deviation produced by a prism, it depends upon the angle of incidence, because this is the sum of both the angle of incidence I plus I dash, refracting angle of the prism, the material of the prism, that fine. Then I dash depends upon the refractive index of the material of the prism, that is the light ray allowed to fall on a given prism at different angle of incidence but not less than 30 degree. So then for each angle of incidence the angle of deviation will be different. Clear? Now here you can see the figure number 3. There is another graph if we determine experimentally the angle of deviation corresponding to two different angles of incidence and then plot I and delta, which is your deviation, so we will get a curve which is showing in the figure number 3. So it is seen from the curve that is the angle of incidence, which is I, increases, the angle of deviation delta first decreases and become minimum. You can see here, so for a particular angle of incidence and the again increases, so for one and only one particular angle of incidence the prism produces minimum deviation. Clear? This is the important one. Now the minimum angle of deviation is represented by which term? Delta m. You can see here the position of the minimum deviation. So the angle of incidence, which is your I, and the angle of emergence is your I dash, are equal. This can be proved as below. Now here is a proof given here. From the figure number 2, ray PQRS, the angle of incidence is I dash and the angle of emergence is R dash. So let the angle of deviation be delta, be minimum, that is delta is equals to delta m. So if the path of the ray is reverse, you can see SRQP. From the figure number 2, you can easily understood it. Just see the figure number 2. So if we reverse the path, that is SRQP, then in that case the angle of incidence will be how much? I dash, and the angle of emergence will be I, and delta will still be minimum. So thus delta is minimum of the when the two angle of incidence I and I, but delta can be minimum only for one angle of incidence. Therefore it is clear that I is equals to I dash from this figure. Now let us suppose n be the refractive index of the prism glass with respect to the air. So applying here is Snell's law, the refractive index, and it comes out to be sin I by sin R, or you can put here sin I dash by sin R. Now let us suppose that if I dash is equals to I and R dash is equals to R, that thus in the position of the minimum deviation, angle ARQ and AQR and ARQ are equal. Hence, if the angles of the base of the prism are equal, then in the position of minimum deviation, the light passes in the prism parallel to the base. This is the most important one, so just pay attention over this. Okay students, now come to formula for the refractive index of the prism. This is the important one. So if the prism is in the position of minimum deviation, then you can write it like I dash is equals to I, or you can also write R dash equals to R, and the deviation comes out to be delta is equals to delta m. Fine. So from equation second and third, we can write it like that: 2R is equals to how much? A, or you can write it R is equals to A by 2. And the same thing we will did for the deviation, which is 2I minus A, or you can write here I equals to A plus delta m by 2. Fine. So we again using here the Snell's law and putting all the values. You can see here we are